I didn't know that, so let me not push it. As you all probably know, Chats is a free community offering from this wonderful library, and our series is sponsored this year by Sherman's Maine Coast Bookshop, and Cafe, and we want to thank them for that too. Our next Chats after today is a week from today on the 3rd of August, and it's a return from Russ Lane, and you will be interested in that too. It has to do with the water houses. But today we're pleased to welcome Dr. Heather Leslie, to speak with us. She's the director of the University of Maine's Marine Laboratory, the Darling Marine Center, and also the Libra Associate Professor of Marine Sciences in UMaine School of Marine Sciences. She's been a member of the University of Maine faculty since August of 2015. She received an A.B. in biology from Harvard, a PhD in zoology from Oregon State University, and conducted postdoctoral research at Princeton University. Before arriving at UMaine, she was on the faculty at Brown University as the inaugural Peggy and Henry D. Sharpe Assistant Professor. She's an international leader in marine conservation science. She conducts research on the ecology, policy, and management of coastal marine ecosystems. Dr. Leslie studies and teaches about the causes and consequences of environmental change in marine systems and how to more effectively connect science to policy and management. She lives with her family along the Damariscotta River in Newcastle, Maine, and happens to be my neighbor, and is a welcome addition to our neighborhood, as well as a welcome addition to Chats. Please welcome Dr. Heather Leslie.
Thank you, Sharon, for that nice introduction, and thank you all for coming. Mel, can you hear me okay?
Yep.
All right, great. So I'm going to try to remember to stay right here. I tend to wander, but it's best if I stay here for the videotaping. I'm really, really delighted to be here today. As Sharon said, I'm director of the University of Maine's Marine Laboratory, so I wanted to take this opportunity to share with you the work that we're doing in Walpole, just 15 minutes from here, and how it connects to marine sciences at the university and beyond the university, particularly here in the state of Maine. I also wanted to introduce myself as one of the 40 people who are in residence at the Darling Marine Center year-round. Right now, our population is over 100. We actually have students who are with us for the month of July who've traveled from all over the world to learn about light in the ocean. So we're pretty much at capacity with 100 people filling every single bed we have, plus those of us who are coming locally every day. But this is a chance really to give you a window into how marine science and marine education is working here in our state, and also how we're contributing to addressing some of the great challenges that we face as a state and really as a globe in terms of environmental and economic change. So before I get into showing you only a couple graphs and talking about science, I do want to take a moment to explain why we moved back to Maine. It was about 20 years ago that my husband and I first came to the state of Maine. He came to do a degree at the university in microbiology and worked at the Darling Center down the road. I came and had many different jobs straight out of college, working for small nonprofits and local shops. And it was hard to leave after our year here. We were married at Pemmican Point, close to where this picture was taken. And even though we moved to another wonderful place, to Oregon, we basically spent the last 20 years trying to figure out how to come back here. And we all have reasons why we're here, short or long term. But a big one for me is the Darling Marine Center. And the fact that what we have at the Darling Center is really quite unique, both nationally and globally. We're one of about a dozen full-service marine laboratories in the country. So there's many, many wonderful places where you can go in the summertime and study snails or learn about birds that live on the ocean. But a lot of those places close up shop in the winter. It's a big operation to keep going year-round. There's about a dozen stations throughout the country, including stations at the University of Washington, at Duke University, Stanford University, and a few public institutions like ours too, that manage to maintain these activities in research and education year-round. So it's a really special place to be. And I came back because I wanted to give back to the Darling Center and recognized after traveling to marine labs all over the world that what we have here is really incredibly unique. So I want to share a little bit about what's going on there with you, but also talk about how my own research in marine conservation is being shaped by being back in Maine, and what my students and I are intending to do next. And my intention is to leave plenty of time for questions, so I'll sort of see where I get to around 10:30, and if I don't get to all my slides, then you can ask me questions and we'll see where the discussion goes from there. Just a little bit of stage setting here. As I mentioned at the beginning, we do face challenges as coastal communities. We're seeing both environmental and economic change that's occurring more rapidly and to a greater degree than we've really seen, certainly in recent memory. And when you look at the shoreline of Damariscotta Harbor, that may not be so evident. One of the things that was striking to me moving back actually was how remarkably similar the twin villages are 20 years after being here. But if you look under the water, or if you look at the state as a whole, we see that there are indeed quite rapid changes. Those changes include waters that are becoming warmer, particularly here in the Damariscotta River, waters that are becoming more acidic, to the degree that shellfish farmers like Bill Mook are actually changing their operations and making major capital investments to deal with changing environmental conditions so they can keep their business going. We're also seeing projections of increased temperature on land as well as in the water. This is a map from a recent report, Maine's Climate Future, that was co-produced by scientists at the University of Maine. And you can see that the changes are not consistent throughout our state. Here on the coast, they're actually quite moderate. We're projecting 2 to 2.5 degrees increase in Fahrenheit by 2050. If you look up, however, in some of the northern stretches of Maine, you see that it may be greater than 3 degrees increase in temperature over this time frame. So these changes in temperature have implications not just for where animals live or the timing that we expect to see blooms of magnolias and other spring plants. They also influence agriculture, water availability, and indeed our fisheries. And in terms of fisheries, again, we've seen some pretty dramatic changes in the last 20 years. This isn't all due to environment, it's also due to changing economic conditions. But it is really quite striking. So if you look what landings were like in 1995, you see that there's quite a wide array of species that people are catching in Maine state waters. These are data from the state, from the Department of Marine Resources. And you see that urchins, shrimp, many species of groundfish like cod and haddock, scallops, and lobster all make up the portfolio of Maine species in 1995. If you look ahead to 2015, data from just a couple of years ago, you see not only that the landings have increased, but they are disproportionately composed of lobster. So we've really become a state that is a monoculture, that we're depending largely on this one species, this very tasty, right now very productive invertebrate that is enabling many people to make a very good living all the way to Eastport. And that's really good news, but it's also, both as a scientist and a citizen, it concerns me because what goes up must eventually come down. You don't need to be a a scientist to know that. You know, there's booms and busts in terms of our stock portfolios. There's booms and busts in terms of the insects on your plants. Well, we expect the same to occur with lobster. So as a scientist and as director of the Darling Center, I believe that it is my responsibility to try to get ahead of this picture on the right and to be working not just with fishermen, but coastal community members more broadly to think about, okay, well, if this is where we are now, what might things look like in 10 or 20 or 30 years? And how do we prepare for that? And what can the university, our scientists, the folks who teach business, the folks who teach engineering, the cooperative extension folks, what can we do to help contribute to the next figure and whatever is in that next figure? If you're interested in learning more about recent trends in coastal communities, I encourage you to check out the Island Institute's report Waypoints. It's a lovely, pretty accessible report with lots of figures like these. You can learn more about how the coast is changing. The premise that I take in doing this science and in essentially pushing or encouraging my colleagues to engage on this issue is that resilient coastal communities depend on resilient ecosystems. And I say premise because it's not going to be the case in every situation that communities and economies thrive because of healthy ecosystems, but we can point to many, many, many cases where that is indeed the case. And in fact, here in the Damariscotta River estuary, so much of our economy, so much of our community is dependent on marine resources. Whether we look at the growing shellfish industry, we here in the Damariscotta produce more than 80% of the state of Maine's farmed oysters. They come, and actually wild-caught oysters, they come here from the Damariscotta. Or whether you're looking at lobster, which has actually been very steady in mid-coast Maine over the last 20 or 30 years. That boom that you see in the last figure comes primarily from communities down east. That's where the big increase in landings have occurred. Or whether it's a little bit more of a distant connection, but still no less important. So many people come here seasonally and short-term because of the quality of environment that we have here. So ensuring that we have healthy ecosystems is really critical to figuring out ways to sustain and make resilient our coastal communities. And when I'm using the word resilience, I'm talking about ensuring that the communities and the individuals who are part of them are thriving, even when environment and economic situations are changing. And that's really the focus of my research. So before I share a little bit about my research, I want to give you a brief introduction to how University of Maine scientists are working to address this larger question. And the question that I have here is, how do we identify and encourage the features of ecosystems and the people who are part of them that help sustain these communities and our oceans into the future? So this is basically how we orient our research and our education. How do we do science? How do we do scholarship and education that enables people and the ecosystems to be more resilient? And before I answer that question, particularly for the Darling Center, I just want to show you a few minutes video that gives you an introduction to how at UMaine we're
to the coast and the ocean. We are people who love to be out on the water, whether it's sailing.
This is my first time showing this video publicly, so it only came out a couple weeks ago.
The Earth is composed 70% of oceans, and look at the state of Maine. We have over 4,000 miles of coastline. A great many of our industries, our resources are marine related.
Our identity is deeply linked to the coast and the ocean. We are people who love to be out on the water, whether it's sailing or catching fish or just exploring new places. The ocean is really important to our cultural identity.
Our coastal economy in the state of Maine is huge. We try to find an optimum level of a catch so that both fishing population and fishing industry and can benefit from the fisheries. That lobster model changed the dynamics in lobster management within the Gulf of Maine.
These buoys that we designed are out there 24/7. They're sending data back to the public and to all scientists every hour.
Every fisherman I know uses it every day to see what the real conditions are then and look at the forecast for what they're gonna
It's the nation's largest fishery. It's Maine's largest export.
So now over 80% of our value comes from one species. That's a dangerous place to be.
We try to keep our finger on the pulse of those babies entering the population.
This is a window into problems that are global in scope.
When the eyes appear, I know that there's actually an embryo inside here.
If we can reduce embryo mortality, then all of a sudden that increases their bottom line, and that's a really important factor for them.
We have new vaccines that are going into fish for sea lice. If we have a major breakthrough there, then we have a mechanism to control the most damaging disease in salmon aquaculture today.
Red tides are one of the biggest public health concerns we have in the Gulf of Maine regions. We need to know when to expect these events to occur. We need to know where on the coast to be looking for it first.
When you look at the demand for seafood and you couple that with Maine's enormous coastline, it's a natural fit.
But there's a lot of opportunity for growth within the industry, and to the degree that the university can help, we're there working with industry partners.
In terms of the tidal power development, knowing what is the risk to different fish populations is what we're trying to get at.
They've been able to really develop technologies, methodologies to get to some of the key answers around how marine life interacts with our power systems.
And marine policy has a special role to play in that in terms of being able to translate all of the work that biophysical scientists are doing to solutions on the ground so people can understand it and say, oh yeah, that makes sense.
Everything is all connected together. The deep ocean is connected to the shallow water water is connected to the land is connected to the deep ocean. We have to study all of these processes to begin to understand how the world really functions.
We've seen an undersea revolution on the coast of Maine.
Marine science has never been more important in the Gulf of Maine region.
We have a number of faculty focused on our backyard, Gulf of Maine, but we understand that the problems in the ocean is global.
This close link between human well-being and ocean health is really important to understand.
Our mission is to educate students in the marine sciences with the goal of promoting sustainability of the oceans.
So that was just meant to give you a flavor of the range of places that we're doing marine science at the University of Maine, and also the range of issues. So you saw natural environments, you saw farmed salmon, farmed oysters, just a whole issues related to energy production and the environmental impacts and the economic benefit of energy production. It's really a very diverse field. And at the Darling Marine Center, we are hosting individuals and have individuals in residence who are working on all of these subjects. And one of the great things about being a field station is that people come to us not just long-term, but also they're often in and out for a week or a month. They come on sabbatical from Europe or South America, and there's just wonderful intellectual exchange. We're also really fortunate at the Darling Center that we're kind of in a bit of a cluster here in terms of marine science. Just across the river, 3 miles down from us, is Bigelow Labs, and there's a great deal of collaboration and complementarity between these two institutions. We have joint projects, we jointly advise students, and we also have the Department of Marine Resources Laboratory on the other side of the Booth Bay Peninsula. So there's actually fairly few places that I've been throughout the world where there are these clusters of intellectual activity, which makes it a great place to be a scientist, because there's only so much you can have at one facility, so being close to other facilities is really important. At the Darling Center in particular, our mission is to connect people to the ocean by doing the type of research you just heard about, and also sharing it with people who need that knowledge, either to make business decisions or to plan how to best steward ecosystems or particular species, or to plan for the future and deal with the sort of challenges that we were talking before in terms of environmental change. And like all land and sea grant entities, we do this work in three important ways: through research, through education, and through engagement with partners in industry and communities. And I just want to give you a couple of highlights of each of those and then describe how my own research fits into this approach. Here I'm showing you a few pictures of research that we do locally. So we have the science diving program for the entire University of Maine system based at the Darling Marine Center. And that enables us to do a lot of subtidal ecology. We have scientists who are discovering new species of bacteria and phytoplankton living on the bottom of the Damariscotta River, observing processes that haven't been seen anywhere before. And the folks who are doing that undersea work can then connect it with studies of commercially valuable species, like what Skylar here in the middle is studying. She's working on scallops and new ways of growing scallops on our experimental lease that's right next to the Darling Center. And here on the right is one of our long-term research sites, Lowe's Cove, where scientists have been studying shellfish and other invertebrates for more than 50 years since our founding. This same cove is also a really important spot for commercial wormers and clammers. And so one of the things I'm particularly interested in is getting the commercial harvesters involved in the dialogue about the changes that we're seeing in the estuary and the shoreline, particularly around the Darling Center, and bringing their observations into the work that we're doing. We do a lot of work locally where we have state support, so of course that's an important part of our mission. But I'd say pretty much every individual who's on the faculty, both here at the Darling Center and in marine sciences more broadly, is also working in other parts of the world. So in my case, for instance, I do a lot of my research in Mexico and work with small-scale fishermen in northwest Mexico, which is actually quite a parallel situation to the small-scale fishing operations that we have here off the coast of Maine. I mentioned before that we have about 100 people in residence right now. That continues into the fall. For the last 24 years, we've hosted an undergraduate program in marine sciences where students are out in the field all day, every day, from September through, well, not quite to December. They tend to spend more time inside once the days get a lot shorter. But we have about 25 students coming in this fall, and they take intensive courses in marine ecology and fisheries ecology, and if they so choose, in scientific diving. So they can actually be certified to do science underwater, and many of our students have gone on and used that scientific diving credential to get jobs in marine science or industry in other places. Finally, one of the things that makes our lab a little bit different than some of our peer institutions around the world is that we actually have business people in residence. Right now, we have 5 different companies who have space that they're leasing at the Darling Center. Those companies range from Sarah Redmaker's Unagi company, which is focused on growing eels out to market size. I don't know if anyone's heard about the Elver fishery. Is that familiar to anyone? So this is a really valuable fishery, and people fish for the very small animals. It's a limited entry fishery, so it's hard to get into that fishery. And poaching is often a problem. There were some fines in the paper in the last several weeks because these small eels are so valuable. So what Sarah's doing with her company, American Unagi, is she is figuring out how to grow these baby eels out to market size. Restaurateurs like to be about this big. And she then sells them to restaurants in Portland and Rockland and Brunswick. She's still sort of in startup mode, but people are buying her product. The eel tastes delicious and sushi and smoked. We had some last week at our Friday coffee, smoked. And her plan is eventually to ramp up production and grow enough eels to really supply the Maine restaurant market. And this means we don't have to then import as many eels from Japan or China where they're raised commercially. So this type of business incubation model where business people like Sarah rent space from us for a given period of time, and they figure out how to make their business model work until they can fledge into a commercial space, is a really important part of our operation and something that we couldn't do without being part of the University of Maine, because we bring down business planning experts to work with people like Sarah. We connect her with people who have expertise in disease dynamics and culture techniques so that she can grow the species the way that she needs to grow it. So it's a lot of resources that come into play being able to host businesses like this. And then we also go to people to their own operations, like Luke Sea Farm and other nearby aquaculture operations. A lot of the collaborations with those entities actually happen at their locations rather than at our site. So to turn briefly to my own research, as I mentioned before, it's focused on small-scale fisheries here in Maine, as well as in northwest Mexico. And what I'm interested in, essentially, is figuring out how to muster the knowledge we have about how coastal ecosystems are changing and how coastal economies are changing, and bring that together with people's knowledge and observations out on the water and in other places, so that we can really come up with reasonable plans about how to deal with the sort of challenges that I introduced at the beginning in terms of changing environment and the boom of lobster that we have right now, which inevitably will decline. So our goal is not only to produce understanding about how these systems work, but also to identify what some of the gaps are so that we can help managers and state and federal decision makers design policy that is robust in the face of uncertainty. So for example, we don't quite know right now, we really don't know exactly why there are so many lobsters. We have some reasonable hypotheses. We have projections of how the numbers of lobsters will likely change in 5 to 10 to 15 years based on how many there are now and how the environment is changing from year to year. But there's a lot of uncertainty there. And so recognizing that uncertainty and designing management measures that are fail-safe, that will work in the face of that uncertainty is really important. And that requires integrating not just knowledge of the environment, but also of how people are behaving in the changing environmental conditions. So I want to open the floor up to questions now. I know I hit on a lot of different areas and probably some that you, or I haven't yet covered some things that you came particularly interested in hearing about. I'll just close by saying that we are engaged in planning for the future of the Darling Marine Center, where we've released our first strategic plan ever, and there's a copy of it over there, a library copy that you're welcome to check out, or if you go to our website, you can download a copy. And it's really important to me that we hear from people like you about whether we're on the right track, whether the vision we have for our next 10 years addresses the needs of community members here in Damariscotta and other parts of the mid-coast. So I appreciate your coming, and I'm very interested to hear your questions and ideas you have for the future of the Darling Center. Thank you. We'll start in the front. Yes.
It seems to me, as I recall, that in the 60s, they placed a lot of restrictions on how you could harvest lobster, and the lobster program improved after that considerably, and maybe in part why we have so many today. Could something like that And I can see some reasons why it couldn't. But could something like that be instituted for groundfish and scallops and so forth?
So the question is about whether there's similar measures, conservation measures that could be put in place for groundfish. Let's start with groundfish as for lobsters. There certainly are lessons we can learn from how the lobster fishery is managed now that would help us think about restoration in other fisheries in Maine. And in fact, the Maine lobster fishery is literally, it's held up globally as a really important example of stewardship. And there's at least two reasons why that is. One is that, as you alluded to, there's some strong conservation measures, including the fact that fishermen are required to throw back lobsters that have young, that are brooding, egg lobsters. And so that enables these females to reproduce before they're harvested. And they're notched so that they're marked as reproductive females, and that protects them for some period of time. That protection of reproductive females is really important. There's other conservation measures that are relevant as well. The other important thing about the lobster industry is that we manage it in a place-based way, and in a way that's that includes knowledge of local fishermen, what's known as co-management. So lobster fishing along the Maine coast is not all done the same way. It's not all stewarded the same way. We have 6 or 7 different zones where people come together on a regular basis and talk about how fishing is going. Fishermen are in contact with the Department of Marine Resources, setting regulations and making determinations about how to proceed. So that place-based approach is also a really important part of the success that we've seen with lobsters. When you look to something like groundfish, the place-based approach is absolutely transferable, and in fact something that a number of us are contributing to developing further in down east Maine. And there's reasons why we're starting that work down east rather than here or coast-wide, and I'd be happy to talk more about that afterwards. But one thing about doing management of fisheries in a place-based way, you want to do it, you want to choose your place in a way that makes sense to the fishermen and also makes sense to the fish. And I've actually come to believe, even though I'm trained as a biologist, I've come to believe it's more important to pay attention to the fishermen than the fish if you have to make a choice, which ideally you don't. Because people have different rules, again, depending on where they are on the coast, exactly how they fish, and fish behave differently depending on where you are on the coast. So understanding those differences in human and fish behavior or lobster behavior are both really important for setting up successful stewardship. And we've been quite good at doing that with lobsters. And there are experiments underway, or discussion of experiments, to do something similar with groundfish in down east Maine. Scallops are also, folks are thinking about it in a place-based way. And there's more parallel probably between managing lobsters and scallops than lobsters and groundfish, because they have they're both invertebrates. Yes?
And what about the shrimp fisheries? How is that?
So they're invertebrates too, so we can learn some things in terms of the biology there. It's been, the shrimp fishery, as many of you know, has been closed now for a number of years, and I don't know as much about it as I would like to. I would say that we're continuing, or the Department of Marine Resources is continuing to monitor the availability of shrimp. There are shrimp out there, and that's been a source of frustration, I understand, to fishermen, that there hasn't been a large-scale harvest in a number of years. But in order to set management measures in a way that can be deemed sustainable, you need to be sure that there are enough out there, not just to be caught, but also to reproduce and to be there in the future. And so apparently the department has made a determination that we're not yet at the numbers that reliably can be caught into the future. And if you want to learn more about that, I'd be happy to put you in touch with somebody who knows more. Yes.
Isn't there some issue concerning the different regulations and the number of regulatory agencies from the federal level all the way down to the local level? I've read some things in the papers about difficulties between oyster farmers, for example, and lobstermen who are trying to use the same area, wherein there's a different way to deal with lobstering, with the pots and the access, as opposed to, I'd say there's probably several different ways that oysters, even in the Damariscotta River, are being harvested. I wondered if you could comment on how difficult is that area, and is there, it just seems there's an awful lot of regulation at a number of different levels for someone who's on a fishing boat to have to deal with.
That's absolutely true, that fishermen, whether they have state permits or federal permits, have a lot of different regulations to keep track of. To talk specifically about the Damariscotta River, my understanding is that historically, oyster farming has been limited to largely north of Glidden Ledge, and there is some south, and there's also seaweed farming south, but historically, it's tended to be to the north, and that's largely driven by temperature requirements. So it's warmer up here. You know, it's easier to go swimming up here than it is down by the Darling Center. And the water warms up sooner in the spring, so you have a longer growing season for oysters. And if you want to get your oysters to market, you want them to grow as quickly as possible, with some other things to be considered, so that you get your money out of the water and into the bank. Again, historically, lobster fishing has tended to be in the lower parts of these estuaries, and we have more than 500 estuaries in Maine based on recent counts. So there's a lot of places where similar things are going on, or they will go on in the future. But what we're seeing now is that there does tend to be increasingly cases where not just lobstermen and oyster farmers, but other uses of the marine environment are coming into conflict. And if it's just a couple of people, usually people can work it out, but in more populated areas or where there's more activities underway at once, it becomes more complicated. One of the areas that my group focuses on is trying to develop tools and science approaches that can contribute to resolving these conflicts. And here in the Damariscotta, we actually have a very long history of doing that. We have the first marine protected area in the state of Maine in Salt Bay. So people have been thinking about deliberate use and deliberate choices of different activities in different parts of the marine environment for literally decades, and that's not the case everywhere in the US. So I'm quite hopeful that because of that precedent and also things that are going on at the state and the federal level, that we can find a path to resolve these conflicts that will inevitably arise. Like it's the same thing being in a neighborhood, and neighbors don't all do exactly the same thing, but sometimes you can talk about it and figure out how to work it out, and other times you need to have a more systematic process if it's high enough stakes or enough people are involved. One final thing I'd say about that is that the towns actually have a really important role in our state, which is somewhat unique. I'm on the clam committee for Damariscotta and Newcastle, and so we manage the clam flats for the two towns at that scale. And we, of course, consult with the state, but we have quite a bit of latitude in the regulations we set for diggers, commercial and recreational diggers in our towns. And that's true for over 100 different clam committees up and down the Maine coast. So I think actually as residents of these communities, we have a lot of opportunity to help shape how these conflicts are resolved going forward, which is important. I know that you had a question for a long time.
So the two pie charts you showed earlier on.
Yes.
Lobster goes from a modest segment to dominating, yes. So all the other segments, is it pollution? Is it climate change? Is it overfishing? Or is it a different story for each one?
It's a different story for each one. I don't know all the stories as well. I don't know them all equally well. Groundfish has been fished out. It's coming back in places, and there, I mentioned before, there's the possibility for restoration, but we have very, very few active groundfish permits in the state at this point. Shrimp, my understanding is that's an issue of environmental variability and change. And so that's the one where the DMR is keeping a close eye in hopes that we can have a commercial harvest again.
Do you mean climate change when you say that? Or
Yes.
something? Okay.
Yeah, warming waters. So the shrimp are they're a northern species. They don't like warm water. And I think they have a lower tolerance for warmer water than lobsters do, for instance. So they're boreal. They go where it's colder when the waters start to get warmer. Urchins we fished out. Urchins was a gold rush, and they're the great thing about urchins is you can't necessarily, and actually all these species, you can't catch every last one. So if you leave a few and you take care of a place, many of these creatures will come back. Groundfish is a bit of an interesting case. Cod, we know that they have they have roots. They have family roots. They come back to places where their ancestors have been for generation after generation. And so in some cases, not just in Maine, but down into Massachusetts and Rhode Island too, we've fished out local cod stocks. And it's then, you need somebody to come in and colonize somebody new. But that memory of the fish's memory literally is gone. So that takes time to replace, but there still are big codfish swimming off the coast of Maine. If we give it enough time and we have enough forethought, we can bring those fish back. And actually, Ted Ames, a fisherman and MacArthur Fellow who lives down east, has done some really groundbreaking work on local cod stocks. So each has a different story. Yes?
Oyster farming doesn't seem to have the same unpopularity as salmon farming.
Yes.
Can you describe why wild-caught salmon are preferable in the fish market to farmed salmon, and whether farming salmon does in fact help restore the wild population?
That's a very good and a very complicated subject. I prefer to eat wild salmon. But I have to say, I think twice about it now. It's hard to go down the street and buy salmon that's wild caught from Alaska or California, where water is an issue, and think about how they got here instead of buying salmon that were farmed in Cobscook Bay. And I think it's something to think carefully about now, think harder about now than it was 10 or 15 years ago. So 10 or 15 years ago, salmon got a really bad rap because there's all sorts of problems associated with farming finfish. Salmon are top predators, essentially. They're, we biologists, we think of critters as being at different levels on a food chain, and salmon are 3.5 or 3.7 or something. They're way up near the top on a scale of 1 to 4. So they eat fish. They need to eat fish. So that means every time you eat a farmed salmon, some other fish went into that farmed salmon. At least some fish, not as much as used to be the case. And in many cases, 15 years ago, the fish that went into those farmed salmon was wild-caught fish. So we were catching little fish, feeding them to farmed salmon that were then sold essentially as a luxury item in another place. So there's not just environmental concerns there about potentially overfishing the feed fish, but also the equity issues of, do you want to take feed fish out of a place where people could be eating the feed fish, like herring, and feed folks like us, farmed salmon. So there's that issue. There's also the pollution. Everything poops, So the waste has to go somewhere, and the disease and nutrient pollution associated with farm fish continues to be an issue, but one that's been mitigated. So these, and then escapes. Alaska actually has no farmed salmon because they do not want to risk their wild-caught salmon because of the concerns about escapes of farmed fish. So none of these issues have completely gone away, but the farming industry has made enormous strides in addressing each of these issues and has done quite a good job, particularly in terms of the fish meal issue. So farm salmon we eat now, they don't eat as much fish as the farm salmon we might have eaten 15 years ago. There's plant-based substitutes that the farmed salmon can eat now. And there's also better regulation of what farmed salmon are fed with an eye to thinking about the sustainability considerations. So it's worth considering where your salmon come from. And I actually went to a fish farm at, down east last summer with my students and was really quite impressed by the operation and how far it, again, had come in the last 15 years. That doesn't mean it's without problems. You can say the same thing about a lot of things we eat. So thinking carefully about who provides the food is probably just as important as what kind of food you eat.
Why is escape salmon such an issue?
Why what?
Why is escape?
Because in some cases they can breed with wild salmon, and so for instance here in Maine we have very, very few wild salmon left, and people are working very, very hard to bring those stocks back. So there's, that's right, yeah, and change their ability to survive in the Damariscotta River and the Kennebec River. Yes, there's a concern about mixing of wild and farmed fish. Now,
how is the anti-science climate in Washington, D.C. affecting funding? Is there an impact at all?
There is an impact. There is an impact of anti-science sentiment. I'd say it's been as much on people's morale as on people's grant funding at this point, because everything takes so long in academia. You submit a proposal and then you wait a year to hear yes or no. So many of us are still waiting to hear yes or no on the most recent round of proposals because they went in before the election. But I will say that I've seen a very, I've been really struck over the last 6 months by how students and young scientists have responded to the anti-science sentiment. And I think it's been incredibly disheartening on a personal level, because it's hard to imagine how you're going to continue in a career when funding seems to be slashed and professional positions in agencies and science organizations seem to be disappearing, and there doesn't seem to be respect for that work. But also a more general sentiment that, that there's not respect for knowledge and systematic inquiry. And so what I've done in response to that is try to show and create spaces where there is still value and respect for those activities. Actually, together with colleagues at Bigelow, we've hosted a series of lunches at the Darling Center, kind of focused on our students, to talk with them about what we understand is changing in Washington and ways to be productive contributors as scientists to activities at the state and federal level. So for all the headlines, I actually am quite hopeful. I visited with colleagues in Washington since the change in administration. They're doing very good work. I think there's a lot about the current administration, while it appears blatantly anti-science. There's opportunities to illustrate the value of science and the benefit economically of science, and that's a lot of what we're about at the Darling Center. A lot of what the work we're doing directly relates to Maine's marine economy. So I'm actually quite hopeful that there's still ways for us to contribute and grow the enterprise. Yes.
The word scientist started out as a pejorative against the believers of Darwin. It was a word used against the physical scientists, and it has transformed quite a bit over the years. It's quite a story about the anti-science and actually the wider anti-intellectual movement that started with Darwin.
That would be a good story for us all to probably eat these days. Any other comments or questions? Yes.
I have a question. Oversimplify. I tell people from away, the Darling Center is the woods hole of Maine.
I think that's great.
How are the two?
But we will never, yeah.
No, but how, Maine will never be Massachusetts. But is there any big thing? Yes, yay. Well, is there any big thing that is different? You know, you've been going for 50 years. I don't know.
Yeah, so I grew up 30 minutes from Woods Hole, and I mean that's part of why I'm here. So I'd say both locations, here in Mid-Coast Maine and in Woods Hole, like I was mentioning before, we have this cluster of scientific activity.
Right.
So we alone are not Woods Hole. We and Bigelow and Island Institute and the Department of Marine Resources and the Gulf of Maine Research Institute, we're a little more spread out, but together, yes, we're very much like the science and training enterprise in Woods Hole. I'd say some interesting intellectual differences, while we kind of came from the same roots of observing the environment and particularly trying to understand how these crazy creatures work that live in mud, because the diversity of critters that live in mud and that live in the ocean is just enormous. You can spend your whole life just trying to identify them all. So that focus on observation and natural history is consistent between locations, but through the years, Woods Hole is focused much more on biomedical questions, like Jackson Lab has. Not exclusively, but I'd say when you look what they're known for worldwide, there's a strong biomedical focus and a strong oceanographic focus. And again, there's multiple institutions there doing that work. Here in the Mid-Coast, I'd say we have, our bread and butter is much more ecological. So even, we do whole animal ecology. We study how baby lobsters respond to changing temperatures, changing acidity of ocean waters. We count fish. At Bigelow, even there, where they're using a lot of microscopes to count critters, they're doing ecology of microbes, of the stuff that's really hard to see. So that's a difference I see, that we have more of a system focus here in the Mid-Coast, whereas there tends to be more of a reductionist or biomedical focus in Woods Hole. People could disagree with that. Yes?
So you alluded to projections on lobsters.
Yes.
5, 10 years out. You said there's a lot of uncertainty. So what are your projections?
So Rick Wally, who's actually upstairs having a meeting right now, who's done some of the groundbreaking work on projecting lobster trends over the next decade. And there's a couple different ways that he and others have done that. So it's a combination of scientists and resource managers who are doing that work. And they were looking coast-wide, essentially, from Connecticut up to New Brunswick. And they're gathering information both on 3 things really, on lobster landing. So how are lobster landings changing through time, what people are catching. They're also putting out traps, different kinds of traps on that large regional scale to look at how many and the condition of baby lobsters and how those are changing through time, and then looking at what the correlation is essentially through time in the number of babies that we see and eventually the number that are landed. But that's, a lot happens to a lobster in the decade between when we see them as a tiny lobster and when we can actually land them at legal size. And so Rick Wally, Bob Stanek, and others are working with the department to try to fill in the other stages of the lobster life history and to understand what trends are likely to be. We do have a prediction that landings will decline, not in the next decade, not in a catastrophic way, but in a way that's significant. And that's predicated on the observed decline in the small animals. And if you want to learn more about that, the nuances of that, you should just Google American Lobster Settlement Index, and you can see the most recent reports that Rick and others have produced.
One quick follow-up. How much of that decline is New Hampshire and south versus coastal?
Yeah, that's a good question. It would take me 5 minutes to pull up that chart. So I hesitate to speak without remembering the 12 panels of that chart. You're referencing another related issue, which is that lobster landings in Rhode Island and Massachusetts have basically gone to zero. Now, the community I grew up in Plymouth, Massachusetts, they're not landing lobsters like they were when I was a kid. And that's environment and harvest pressure and disease. So we're not seeing that in Maine much yet.
It's breeders.
And the trends that are projected for the next decade, yeah, they don't take us to that zero place at all. But there is expected to be a bit of a bump based on the settlers that we're currently seeing out there, the little guys. Yes, in the red.
I just was curious in terms of the landing. I think you mentioned that mid-coast was level.
Yes, it's been pretty steady actually over the last 2 or 3 decades based on the data.
Was growing.
Down east is growing enormously.
Is that because of harvesting increase or climate changes?
Yes.
Or
yes.
Yes.
Yeah, so landings, I mean, the capacity of people in Stonington to land lobsters has gone through the roof. The number of lobsters and the value of lobsters landed in Stonington, which is the top port in Maine right now, has gone through the roof. So it's better lobster country farther north than it was a couple decades ago. But many of us believe that that's not the whole story, that there's a synergy between how the ecosystem is changing and how people are responding to those changes. Yeah. In the front row, yes.
Some years ago, there was an order issued by the district court judge, federal district court judge down there concerning the closure of Deer Island sewage treatment plant. And they completely stopped all hookups to any construction in the city of Boston and surrounding area because of the pollution. And the reason they found that is because a plane went off the runway at Logan, and the seats of that plane floated down into Cape Cod Bay, and that is the first clue they had that every single bit of pollution, which was in the millions of gallons that was coming out of Boston, was washing up on the shores of Cape Cod.
I haven't heard that.
When you tell me that the lobster population in that area has plummeted,
yes.
Is there some connection to, and I know they cleaned it up, I mean, they spent a lot of money to clean all that up, and it supposedly is cleaned up now. So is there some relationship to that in terms of getting rid of pollution that impacts on lobster landing?
I have not heard any discussion of a connection between pollution, particularly in Boston Harbor or offshore, and lobster landings in Massachusetts. I can think of where to look. I mean, certainly the Maine Department of Marine Fisheries would be the folks monitoring that, and I'll look into that. I suspect there's not a direct connection. We know waters off of Boston have gotten warmer in recent decades, just as they have in the Damariscotta and in the offshore waters here. And at some point it takes a while for them to become uninhabitable by lobsters, but they become less comfortable, and also it becomes easier for disease to take hold. And that disease has been a real issue, in addition to die-offs related to warming waters in southern New England and Long Island.
Thank you.
I think we have time for one more question. Anyone who hasn't had a chance to ask one yet? How about in the second row? I think you had your hand up longest. Yeah.
Well, you had answered some similar questions, but
I guess when you look at some other coastal areas throughout the world, they're having serious problems with warming waters and erosion, and there is some of that going on the Damariscotta River. So I guess, you know, and that will affect lobster as well, the ecology. What do you see the forecast? What's being done? I know it's minimal now, but it is happening. If you're on the river, you can see it happening. And you can see the changing, you know, the sea life that comes in one year because it's warmer and others go away. So in terms of being very specific in terms of where the Darling Center is, what do you see forecast for that? What's being done to?
That's a really big question. Maybe two quick answers. One, as a marine station, part of our responsibility and opportunity is to pay attention to what's going on around us. So we've been collecting data on the critters who live in the ocean around us for 50 years. Many of those data I can't put my finger on if I tried today. So once we get through this strategic planning and revitalize the waterfront, we're in the process of building a new pier and flowing seawater lab right now. Once I get those projects off my desk, the next project will be to work with all my colleagues and visitors of the last 50 years to get our data in a format that we can share. Not only so that you all can see it, because you can see quite a bit of our stuff we're doing right now. If you go to the website and can dig for it, and if you can't find it, just ask me. But you can't necessarily see all the historical data that we have access to. So I think we could do a lot better job of sharing that information, and in fact, it's part of our responsibility, being a university institution on the river, to archive that and to disseminate that. And some of the ways we're being pushed and enabled to do that sooner rather than later are through our collaborations with citizen science groups. We're working closely with the Damariscotta River Association and organizations throughout this area on something called MCOA, or the Mid-Coast Coastal Observing Alliance. And we are serving data and analyzing data for that group related to water quality on estuaries all throughout this region. But the other, I guess the other piece, somewhat tangential to what I just said, is that the Regional Planning Commission, the Lincoln County Regional Planning Commission, is very actively engaged in thinking about another dimension of coastal change, sea level rise, and enabling community responses, municipal responses to sea level rise. And so I've been in conversations with Mary Ellen Barnes and some of the commissioners about how we at the Darling Center, but also University of Maine scientists more broadly, might be resources or partners in some of the work that's going on with the towns and through the Regional Planning Commission. So it's an active area, and I'd love to hear feedback on where it would be most usefully directed from your point of view. I think we have to stop.
On behalf of Chad's